Hello again, and welcome to the next video in our lesson here in Unit 4, System of Linear Equations and Inequalities. Today we're going to be talking about solving systems of equations by substitution. Here's our learning target. We're going to use the substitution method to solve system of equations. And the essential question is going to be how do you solve a system of linear equations by substitution. So make sure that you go and get those learning targets written down and you write down this essential question as well. Vocabulary, so these two vocab words that are currently listed on here, we have substitution. And what substitution means, basically putting numbers where the letters are. So basically, if x is equal to 3, so for every x that you see, you're going to substitute in 3. And the basic idea of the substitution method is a method of solving a system of equations by replacing one variable with an equivalent expression containing the other variable. So that's the substitution method. And we've kind of used substitution before, where we substitute, you solve one equation for a variable and then substitute the solution into the system's other equation. So we solve the variable and substitute its value into one of the original equations in the system and find the value of the second one. That's what we're trying to do today. Now we've kind of done this before, where we've solved for a number, and we just take the number, and we substitute it in for the variable to find the other one. So the first example, we know y is equal to 9. So instead of writing y in that first equation, we're going to write 9, and that's set equal to 3x plus 6. And then all we're going to do is solve for x. So in this instance, x is going to be equal to 1. So our solution here would be 1, 9. In our second equation, we are going to substitute in 5 for x and solve. So 2 times 5 is 10 minus 4. And y is going to be equal to 6. So our solution is 5, 6. As I have written on the screen here. So those are the big ideas. So let's actually apply what we're trying to do in this topic. What is the solution to the system of equations? So on my screen is y is equal to 6x plus 7, and 3x minus 8y is equal to 4. So what we're going to do is I'm going to circle this first equation, y is equal to 6x plus 7. You see that is set equal to y, and we're going to take that and substitute it in for the second equation, 3x minus 8y is equal to 4. So we're going to rewrite this equation. Oops, sorry. That's what we're going to do in this one. So I apologize. The first step, substitute first equation into second equation. So we're going to take this, substitute it in for y. And what it should look like is like this for step number 2. We're basically now going to solve this for x. It's very important that you have these parentheses in here, because what you're going to do is you're going to use distribution. You're going to distribute this negative 8 into the parentheses here. So it's very important that when you use substitution method, you use those parentheses. So if 3x is minus 48x, minus 56 equal to 4. So now 3x minus 48, that's going to be negative 45x. We're going to add 56 to both sides and get 60. And then we're going to divide negative 45 on both sides. And then x is going to be equal to 60 over 45, negative 45. And then if we divide both sides by 15, we get that x is negative 4/3. So that is what x is. Now, once we have x, we're going to substitute x into either equation and solve it for y. So it would be probably the quickest to substitute in for the first one. Y is equal to 6, and then we're going to substitute negative 4/3 for x and add 7. So 6 times negative 4 is negative 24. 1 times 3 is 3. So negative 24 divided by 3 is going to be negative 8. So then we have y is equal to negative 8 plus 7, which then is just negative 1. So our solution is 4, negative 4/3, negative 1. Now the next example, what is a solution in the system of equations? So we're just going to do this again. We're going to take the 3x plus 1, we're going to substitute it in for y. So now we have 6x minus 2, 3x plus 1 is equal to negative 2. We're going to distribute the negative 2 into the parentheses. So we have 6x minus 6x minus 2 is equal to negative 2. Add the 2's over to both sides, and then we have 6x minus 6x is equal to 0, and then combine the like terms, and you get 0 is equal to 0. Now, when you look at that, and you see that 0 is equal to 0, you're probably wondering, well, what the heck's going on here? Or you might have a situation where if you just combine the like terms, you have negative 2 is equal to negative 2. Well, if you notice, both sides are equal to each other. So it doesn't matter what we're going to substitute in for x, we're going to end up with the same answer. Thus, in this situation, we can say there's infinitely many solutions. Now, on the new one, we're going to take the second equation, we're going to substitute it into the first one. Now, this is where using the parentheses are going to be so important. If you didn't put the parentheses in here, you would think to just subtract the 5x's together, and then you're left with negative 4 is equal to negative 4, and you're thinking, oh, infinitely many solutions. Avoid this trap. We distribute the negative. So it's negative 5x plus 4 is equal to negative 4. And if we just combine the like terms, so then we just have 4 is equal to negative 4. And if you just want to subtract the negative 4 over to both sides, we have 0 is equal to negative 8. Now you're probably sitting here and wondering, well, how in the world can 0 be equal to negative 8? That doesn't make sense. Well, this is the situation where, since two sides are not equal, we don't cross anywhere, right? So there's no solution to this one. The lines are parallel. So if you ever have a situation that looks like this, you can say that the system has no solution. And now, the real-world example, we're going to model using a system of equations. So Nate starts a lawn mowing business. His business has expenses and revenue. Nate's expenses are the cost of the lawnmower and gas. His revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? So basically, we're trying to figure out the intersection point. So how many lawns does he have to mow in order for him to make a profit? So we need to set up an equation. First of all, what are his expenses? Well, he's paid $200 for the lawnmower, and gas is 2 per lawn. So we're going to call it L. We're not going to use X. We're going to use L for lawn. And the y coordinate is going to be money. The second equation we're setting up is that he makes $25 per lawn, so it's 25L. So we're trying to figure out at what point will Nate's revenue exceed his expenses. So the easiest thing to do is, since we've set both of these equal to L, so we get 25L is equal to 200L. Sorry, 200 plus 2. Blah. So try that again. 2L. Then we're going to subtract 2L to both sides. You get 23L is equal to 200. And then you just divide. You get 200 divided by 23. Now, in this problem right here, we're not so concerned about the money itself. We're just kind of concerned about what point does he mow enough lawns. Now, the thing about this one is you're not going to come up with an even number. So if you take a whole number, so you get like approximately, I'm just going to round, you get approximately 8 7/10. Now, you can't mow 7/10 of a lawn. So again, at what point will Nate's revenue exceed his expenses? So the answer to this would be at 9 lawns mowed. So that's the one thing you need to think about. And this problem is, oh yeah, you got to round it to the nearest whole number because you can't mow 7/10 of a lawn. I don't think the people that are getting their lawns mowed would be appreciating 7/10 of a lawn mowed. So here's the concept summary. So we already know the graphing situation. So we didn't talk about solving it by graphing. There are advantages to solving it by graphing, but there are also advantages to solving it by substitution. Sometimes it'll be easier to graph, sometimes it'll be easier to do substitution. So this one's just kind of showing both situations here. So go ahead, there are 4 problems that are on your notes that are the try me problems. I want you to go ahead and try those using substitution, and ask questions if you need it. I'll see you at the next video.